All right, year 2018, question 2. Okay, so this is a bus company that conducts a sightseeing tour that the tourists can get on and off of the buses at any attraction as many times as they like. So you are given this weighted directed graph. Okay, where on the each of the age you can find the time that a bus takes to travel from the different attraction. Okay, so there are two different circuits given as well, represented by like different road here, road 1 and road 2. Okay, so complete the adjacency matrix for the diagram. So I think this is quite straightforward. So you only left with the row F to settle. So that's why we only look at row F. Okay, so for the vertices F, then you can see that the only way that it can go to is actually C. All right, so in that case, then you know that other than that, it will be all excuse me. Other than that, it will be all 0. Okay, so that's why you have 0, 0, 1, 0, 0, 0. Okay, so remember that in the matrix itself, you are not writing the weights, yeah? So you are only writing like how many ways you can do that walk, right? Okay, so you can see that from C, so from F, that's the only way to go from F. The only way that you can go is actually FC. So other than that, they are all 0. Okay, so if you are writing, so which means that successfully identifying all the 0, you get 1 mark, then get the 1, you get 1 mark. So Mai gets on the bus at E, so she travels directly to B, changes bus, and continue to traveling for B, F, C, D, E, A. Okay, so the easiest way that you can do is you can just try to draft like where is the path that she actually go through. So she gets on bus at E, so this is where she is. All right, then she travels directly to B. So this is the path that she take, because travels directly, right? Okay, then after that, she continue traveling for B, F, C, D, and then continue with E, and then go to A. Okay, all right. So the question asks, explain why her route is a trail. So you can see that when you try to go through this walk, E, the vertices E, the vertex E has already repeated. So that's why this cannot call a path. So that's why is it a trail? Because you do repeat the vertices, but then there is no edges repeated, right? So that's why. How do we explain why it is a trail? Because it is a walk with no age repeated. Okay, so it is a walk with no age repeated. All right, so states that it is a walk, you'll be able to get 1 mark, okay, because trail is basically a walk, right? Then you tell me that the trail is a walk that with no age repeated, then you get the 2nd mark. Okay, then we move on for C. So Vin has just visited attraction C and wishes to visit attraction B next. So state the route that he should take to arrive at B in the shortest traveling time. Okay, so this is a bit similar to what you have in the shortest route. The only thing is just that now your graph is a directed graph, but the way that you are doing it is supposed to be the same. Okay, so Vin has just visited attraction C. So which means that now what happened here is that Kevin is at C. So she wants to go to B, but there's no direct way, as you can see, because the age here show that you can only travel from B to C, but not C to B. So if you want to go from C to B, then you can try to check out. Okay, so in this case, from C, the only way that you can go to is either take CE or either you can take DE, right? So in this case, because she wants to travel a shortest route, so that's why you can see that 5 plus 7 is eventually shorter than you are taking 14, right? Then after that, same thing. If let's say from E, we want to reach BE, either you go through the 12 here or either you can take 5 and 6, that gives you 11. So if we want the shortest one, then definitely we are going to choose the 11 one. So that's why this is the shortest route that will allow me to reach B. So that's why I will take C, D, E, A, B. Okay, so C, D, E, A, B. Then after that, I'm going to add up all the minutes just now. So 5, 7, 12. So 12 plus 11, you got 23. So that's why 23 minutes. Okay, so successfully get the shortest route, then that will give you 1 mark. Then after that, you got the shortest time, then you get 1 mark. All right, so for this question, because the question didn't tell you like to show specific working, so that's why it's fine that you can just use, some mental reasoning to do that. Okay, so just leave your answer like that. So the bus company plans to include another attraction, so which is G. So instead of adding another circuit, they provide shuttle bus that, can go to and fro from G to F and also from D to G. So Toshi is at attraction D. He wants to complete a Hamiltonian path. So state the route that he should take. Okay, so for Hamiltonian path, there's no way that you can do it like straight away. The only way that you can do that is try and error. Okay, so that's why at D. So you can see that if let's say he want to travel from D, the only way is that you can go to E or you go to G first, right? So in this case, then we just try out which is the one that work. So if let's say I choose to move from D to E, if let's say I want to create a Hamiltonian path, then definitely I wouldn't take I wouldn't take this one, like, because I will want to go through A at the same time. After that, I go to B, then I continue to go to F. Okay, so now you realize that you're having one issue here is that for Hamiltonian path, you need to include all the vertices once, right? So if let's say you choose to go to G, then you wouldn't be able to reach C. If you choose to go to C, then you wouldn't be able to reach G. So that's why you know that this way doesn't work. Then now what do we try to do? We try out next direction. So which means that except go to E, D can actually go to G as well. So if I'm at G, then I will continue with F. So now the thing that I will need to think about is how do I try to create a road that include all the rest of the four vertices here. Okay, so when I add F, then you can see that C is the only way that I can go to. So of course you can try to go to E first, or in this case, you can try to go to D. But then since you already included D, so we are not going to go through D anymore. So that's why E, A, B. Then now you can see that you find a path that include every vertices once. So you realize that no matter how you do it, you are not able to end at D again. So that's why they are just asking you to find a Hamiltonian path. Okay, so state the route. So that's why you have D, G, F, C, E, A, B. Okay, so in this case, then the answer key will be in such a way that if let's say you are successfully to find a path that include all vertices, then you get 1 mark. So then after that, if you are able to find one Hamiltonian path, which means that, okay, if let's say you are able to find a path, so you include all the vertices, but then you are not included all the vertices once, in that case, then you get 1 mark. So if let's say you are able to get a Hamiltonian path that include all the vertices once, then you get your 2nd mark. Okay, so that's how the marks are given here. All right, so that's it for this question.